Okay, and here we are.
We are ready for this? All right.
Ready? Yes. All right.
Woo! JavaScript testing! So as Vijay said, my name is Mike Gehard. I work for a company called Pivotal. Our office is right there, I think. We're at 1333 2nd Street on the second floor. I'm actually based out of our Boulder office. I've been here since the beginning of April, helping out with a project we're running here. I go back to Boulder at the end of June. And I've been asked to talk to you a little bit about JavaScript testing. So how many people actually write JavaScript, like for a living, get paid for it? How many people don't get paid for it? Sweet, you should be testing too. How many people test their JavaScript? Like legitimately test their JavaScript? Yeah, that's what I thought. Automated testing of their JavaScript. So you test your, I hope you test your JavaScript, because like if you're not testing it and it's broken, how do you know it's broken? So we're gonna go through a library called Jasmine. So Jasmine was written by a couple of Pivotal engineers, who I don't even know, probably 5 years ago. We firmly believe in testing, so we test drive everything that we write. So I don't write a line of production code until I have a failing test for that. And we'll go through a little bit about my test-driven flow and how that works and what that looks like. Is there any questions before we get started? About me, about JavaScript testing, about just? Cool. As we go through the talk, if you do have questions, please bring them up at the time that you have them. Instead of holding on to the end, I just find it's a lot easier to talk about them in the moment than remember, like, oh yeah, you talked about that thing on slide 4. Can we talk about that again?
What version of Jasmine are you covering?
I am running version 2 of Jasmine. Somebody has told me that Angular is only running version 1, and the differences aren't that big. I'm really not going to teach you the syntax of Jasmine today. I'm going to give you a little flavor of that, but the docs are really good. I'm going to give you really today the flow. Like, what does it look like when you have a new requirement from a business owner and you need to implement tests and implement production code to get that done? The flow in Jasmine 1 and Jasmine 2 are the same, so and the docs are really good. Any other questions before we get started? So why do we test? One of the reasons I test is to document system behavior. So nothing worse than a new developer coming to you to start the project. What does the system do? And then you have to spend, days, weeks, months, if the system is really big, telling them what it does. So I like to say that my JavaScript tests document system behavior. So I can kind of turn somebody at the tests, and they can get, hopefully if I do my testing well, a generic idea of what the system does. If your tests don't tell somebody what the system does, then your tests are probably no good, and maybe we should talk about that. But really just what does this thing do? I also like to say test-driven development gives me design advice. So as I'm writing JavaScript, the first client of my JavaScript that I'm writing is my test code. So I can now get design feedback, and TDD talks about design feedback, and there's this whole theory that if you can't write a test for something, that your design is wrong. It's not the test's fault. So we use that as feedback to help us actually get better code in the long run. To enable refactoring. Does everybody understand what refactoring is? Does anybody understand what refactoring is? Okay, what is your definition of refactoring?
It's making the code cleaner and more efficient.
Without changing external behavior. So that's the key, is refactoring. And there's this big misconception about refactoring these days. There's an amazing book written by Martin Fowler called Refactoring. I suggest you read it. It's all written in Java, so you'll have to learn a little bit of Java. But refactoring is my ability to change code without changing external behavior. So it's cleaning up code. It's renaming variables and all of that stuff. And if I don't have a test suite, Martin says you cannot do refactoring. Kent Beck says you cannot do refactoring, because how do you know you haven't broken something without plugging away? So our test suite becomes that safety net with which we can just get all aggressive on our code and make it better. It helps with the blank canvas problem. Does anybody know what the blank canvas problem is? You ever sat and stared at like a blank screen and be like, where do I start? So this helps with the blank canvas problem. I can write one test, and I can make that test pass. And then I can write another test, and I can make that test pass. And it kind of gets you rolling and gets you moving towards your end goal. So you're taking these little small chunks of functionality, writing a test for them, and then implementing them. And this has helped me enumerously. It's literally like, what do I do next? I just make the test screen. What do I do next? I write a red test. So there's this flow that we get into, and we'll talk about the TDD flow of what that looks like. With JS, it also technically acts as my compiler. Does anybody know what I mean when I say that? It acts as my compiler?
It'll tell you what errors you have.
Yes.
There's no compiler.
JavaScript doesn't have a compiler. It's a runtime interpreted language. So if I fat finger a variable name, I do not find out until I've run that code that it is broken. In Java, the compiler would tell me. It would do static analysis. It says, hey, you've asked me for a variable called foo, and you don't have a variable called foo because you called it bar. So it gives me the ability to have this thing that will very quickly run my code to make sure it's not busted. And now I'm not talking like busted functionality-wise. I'm talking busted like I mistyped that variable name. So it's this really fast feedback loop. So that's why I test. I think it helps me write better code. It gives me a safety net. It lets me sleep better at night, literally. Like I know I can make changes at will, and if my tests are all still green, then I haven't broken anything from a functionality standpoint. So we use something called Test Driven Development. Anybody read the Kent Beck book, Test Driven Development by Example? Highly recommend it if you haven't, again in Java, because the Java guys figured this all out 15 years ago. Talks about what test-driven development is. And I'm not going to go into the details of test-driven development because it's a little bit long. But the greatest thing about TDD is there is a flow. There are 3 steps to test-driven development. The first one is the red step. I write a failing test. The second step is I make it green as quickly as possible. So Kent Beck talks about shameless green. I don't try to get fancy with the code I'm writing. I literally make the test green. Because in the next step, the refactoring step, I now can go back and make it better. So I don't have to get all wrapped around the axle of like, am I using the right name? Am I doing this thing the right way? The test is green. My job is done. I can now go back and refactor that code. Why do I make the test red first? Why do I not? And also, why don't I like testing afterwards? They have the same answer. If you write a test afterwards, do you ever know that it fails? Do you ever see it fail? You ever been in a test suite where you change a bunch of code and none of the tests fail? There's nothing worse than like making changes and knowing stuff is broken and none of the tests fail. It's like learning trapeze with gigantic holes scattered around the net. And you have no idea when you're going to fall off that bar. And if you happen to hit the net, awesome. If you happen to miss the net, then you've got some issues. So this is why I do not like test after. You have a lot of chance of writing what we call evergreen tests, tests that never fail. No matter what you do to the code, they're always green. And those are scary. Because you're like, yeah, I got a test suite, and they're all green, and production's broken. And you're like, oh, that's not so great. So this is why we go red, green, refactor. And we just do this over and over and over again in these little iterations till we're done. And how do you know when you're done? When your tests are all green. This is another reason I like writing tests first, because how do I know when I'm done? If I don't have to write any more tests, and the tests are all green, then I'm done. There's no more what-if edge cases. Any questions on that? Yes?
I heard that one of the reasons is your minimum requirement, you do just enough to make it green.
Yes.
And so that keeps it all.
Yes, so TDD was born out of the Agile Manifesto. If you haven't read the Agile Manifesto, another great document to read. Kent Beck was one of the signatories. You do just enough. So it's one of those things where I don't like, as developers, we get off into these rat holes. Like I've ended up in rat holes. 2 hours later, you're like, what have I gotten done? A lot of stuff that I may not need. So I want to just make the test green. This is why I write the smallest amount of code to just make the test green. Because if I have code that doesn't make a test green, what problem do I have? Is that test right? If I change that code, no tests will fail. So again, we get into this like, hey, I don't know if everything's tested. So people are like, well, it seems limiting, and that's great. If you want to write more functionality, write another test for it. Ask your product owner if that functionality is actually needed. So it allows us to follow that agile process of minimum viable product. The simplest thing that could work. Not the simplest thing, but the simplest thing that could work. And we measure could work by the test going green. And this is hard. Like How many people don't write tests because this is hard? Like, I used to not write tests because this is hard. And it's like anything else. Like, if you don't practice basketball all the time, basketball is going to be hard. So comes with practice. This is something that you learn. This is a skill that can be taught. This is not something where we magically are great testers. This is a skill that can be taught, and these 3 steps help us get to that point. Any other questions before I move along with that? So I kind of alluded to this. Your first primary job in test-driven development is to get the test screen. Don't get fancy. Don't go crazy. Boring code is good code, in my opinion. Just get the test screen. Okay, does anybody know the 4 parts of a test? Anyone want to take a guess? Yes?
Prep,
Setup, prep.
call, and then assert.
Yes, prep, setup, call, or I call it do something. Assert, so like expect something to happen, because if you don't have any of those, then why, like what's going on? What's the 4th one? Tear down. So I've set up, I actually exercise, I set up the world, kind of the state of the system. I exercise the object under test, so I call a method typically on that object. I then assert that something happened, either some side effect or I got a return value that was some value, something that I expected to happen, and then I tear down. So you guys got them all. And that's it. Those are the 4 parts of a test. Every line of code you write should fall into one of those 4 categories. Then there's the age-old discussion of 1 assertion versus 2 assertions versus 3 assertions. Anybody have an opinion on that? Some people have very strong opinions on that. What is your opinion?
My opinion is 1 assertion.
Okay, cool. That is a very valid assumption. My goal when I write tests is I want my tests to read like little self-contained stories. So each test it should have like a setup. I should be able to understand what I'm setting up. If you can't understand what you're setting up, then maybe you don't understand what you're doing. You should be able to see like, oh, right there, that's where I poke the object in question. And then I have some assertions that are kind of like the finale of the story. Like, here's what happens at the end of the story. If 1 assertion makes the story complete, awesome. If more assertions make the story complete, awesome. If you get to more than 2, you might want to question your story might be too long. You might be writing War and Peace when you need like Aesop's short fables. So it's hard to tell. Like, I try to lean towards 1, but sometimes there might be 2 in there. And there are ramifications of writing 2. We're not going to get into those ramifications, but there are like everything in engineering. Kent Beck said in a tweet a couple of weeks ago that like every decision in engineering, the answer should start with it depends. So it depends on what you're trying to do. There's no hard and fast rules for this stuff. And that's what makes it so hard. As beginners and as learners, we want, well, I follow these 6 steps and an apple pie comes out of the oven. Well, you follow these 6 steps and like a cherry pie comes out of the oven. We're like, well, it depends. Like maybe the oven was magic. But it's really tricky. It can be really tricky. So that's all the talking I have as far as like background of TDD. Does anybody have any questions on that? So I'm going to do some live coding. We'll see how this goes. As anybody's done live coding, it can be tricky. So bear with me as I fat finger half my variable names as we're going through this. So yeah, if you want to follow along, there's a repo here that you can clone. So what we have here is, let's make sure I have, okay. So let me minimize. This is my cheat sheet, this other IntelliJ window, so that's what that is. Okay, so on the left, I have running test suite, and I'll bump that font up so you can all see it. No, that's the wrong. Okay, so I have a failing test. And on the right, I have my IntelliJ window, which I will be doing my coding in, and I probably need to bump the font up on that as well.
So everybody okay with the font?
Yeah, can everybody see the terminal window? And that you probably can't read, so let me bump the font up on that.
What we'll do is we're also recording it, so
Yeah.
For you to look at later. And then if you'd like to follow along with Mike, you can
Yeah.
download the repo like you said.
And you can download the repo. The solution is in the repo too. So if you learn better just by listening along, totally cool. Can I command plus that? I can't. I don't think I can do that in IntelliJ. I think IntelliJ I have to physically bump up the font size, and I can't do anything about the font size here. So unfortunately, okay. So here we go. First step of red green refactor is red. When I write tests, I always start with this test just to make sure the testing framework is running. So this test doesn't do anything, it just fails. I want to see that it fails. That tells me like, yep, Jasmine is set up properly. So what I'm running here is I'm running Jasmine, I'm running Node, and that's it. So this is going to be kind of, I'm going to write a little class that we're going to test drive using Node. If you're doing jQuery setup, there's tons of articles on the internet of how to use Jasmine to test various frameworks. I decided to do this because it was just a lot easier. Okay, so what's my next step? Green. What is the simplest thing I can do to make this test green? Except false to equal false. Okay, sweet. Now we're green. We're done. Ship it.
Is that an accurate story though? Like if your test is supposed to fail, but it passes?
So this is simply my mechanism that I use to make sure everything's working properly. So I know I need to see a red test. I know I need to see a green test, and I know I can now refactor. So I'm now simply testing the testing framework is set up properly. Because there's nothing worse than having your test framework not set up properly, and you're like 4 tests in, and nothing fails. You're like, oh, I haven't, like, it's not, I've had that where it's not picking up my tests.
So that's the method.
Yeah. Yeah, so this is what I'm doing here. So this is kind of, that's it. So we've gone red, green. Do we have any refactoring opportunities here? No, that looks pretty good to me. I'm not sure I can make that code any better. Okay, so now we have requirements. So the first thing we're going to do is we're going to write this little music player thing, and I'm going to start test driving this out. So my 2 requirements are that a player by default is not playing, and a player has a null current song. So I'm going to start out by creating a new test file called player. Actually, let's call this player spec. JS. And I am going to simply copy this to here, move this to the right directory, and delete this test file. OK, let's see what happens. It still passes. It still fails. OK, sweet. We're good. You'll notice I'm going to go to this terminal window probably more than you ever probably have gone to your terminal window. I make super small changes, and I run the tests. Because if tests stay green, then I can just keep going. Tests go red, then I'm like, whoa, maybe that refactoring went south. So that was a refactoring. So now I'm going to say describe the player class. It, by default, starts out not playing. I find that if I can't write the text in there that reads like an English language sentence, that I don't understand what my test is supposed to be doing. So simply by writing that test, that text, I can start to think about like, okay, what does my setup look like? So what's my setup going to be here? So I need the object under test. So there's my object, and I'm going to assert dot is playing to be false. Playing to be false. So that is my first test. My first requirement was, by default, the player is not playing. By default, I have not done anything with this player but new it up. I expect is playing to be false. Test number 1. Anybody want to guess whether or not that passes or fails? Yeah, it fails miserably. So when I talk about compiler, this is where the compiler aspects come in. It's not told me, I haven't even written the player thing yet. So I need a player thing. I'm going to write player.js. I'm going to do Now I have to go to my cheat sheet because this uses node syntax and I haven't written node syntax in a while. So let's go find my cheat sheet. I'm just going to start copy and pasting some code. All right. So let's do this. And we'll delete all this. OK. So I believe that that is the minimum amount of code that I need to make the test pass. Am I right? No. What am I missing? The is playing property, but what is the error message telling me? So this is the other thing you get good at when you do TDD. You get really darn good at reading error messages. What is that error message telling me? So player is still not defined. I know I've written the class. I know I've written the function.
You haven't set up the class within the test.
I haven't set up the class within the test. All right, now I'm going to go back to my cheat sheet.